Hey guys, how are we doing? So today we're going to go over insulating buildings, something that's super important for you guys, especially because it's getting so cold outside. You probably want to tell us to your parents, your family, your carers to make sure that you save them lots of money. Okay, so that's why we insulate buildings. We insulate buildings because we want to save money. So, for example, buildings are things like your houses, your flats, right? And we want to insulate them. The reason we want to insulate them is because we want to reduce the heat loss. For example, if I'm paying for loads of money to get my heat inside my home, to pay for the provider, I use Octopus, whatever you use, to get my radiators to turn on, okay, I'm paying all that money to heat up my home. I don't want that heat to get lost, right? Because if the heat leaves my house, then it's not staying in my house, keep my house nice and warm. Okay, so the same reason that we insulate buildings is the same way that when you go outside really cold, you insulate yourself, right? You wrap yourself in a coat, you wrap yourself in an insulator to keep yourself nice and warm. We don't want to lose that heat from our bodies. So insulators, what we say they have is a low thermal conductivity. Okay, so low thermal conductivity. So low thermal is obviously to do with heat, like thermal clothes. So low heat, low thermal conductivity. So someone's a good conductor, it lets things pass through you, okay? So low heat conductor. So an insulator doesn't let heat pass through it easily, right? They're actually really slow at conducting, if I can spell, they're really slow at conducting heat, okay? So what's the difference then between an insulator and a conductor? So obviously a conductor is something that is D-U-C-T-O-R, I can't spell today. A conductor is something that is really fast at conducting heat. The opposite of this. A conductor is really fast at conducting heat, so it has a high thermal conductivity. Conductors have high thermal conductivities. They're really good at conducting that heat. So let's say we have an insulator. That's maybe an insulator might be wood, right? So for example, or plastic might be a better one. We know insulators are plastics. So plastic or woods, either one you want, but we know they're solids. So I know got my particles in my regular arrangement. Okay, but let's think about things that are conductors, things that have high thermal conductivities, things that are really good at conducting heat. And in this case, also electricity, are things like metals. Okay, so metals are also solids. So we've got our particles in a regular arrangement, they're all touching. So what's the difference between these insulators like plastic and wood and these conductors like metals? Why are metals much better at conducting that heat? And the reason is because metals also have these things called free electrons or delocalized electrons. So these electrons, you can call them free, are just able to move through that structure. And because they can move through the structure, they can transfer that heat really quickly. Whereas in insulators, what happens is the only way they can transfer heat is that basically what we're going to do is we're going to heat up this particle. That particle then is going to vibrate more, right? It's going to have more vibrations. When it vibrates more, it hits the particle beside it, it's going to vibrate more. Hit the particle beside it, it vibrates more. So all that vibrations then pass along, but because it takes time for them to hit each other and make each one vibrate, that takes a long time to conduct that heat. We know that insulators still conduct heat, right? You know that if you were cooking your food and you left the plastic spatula on the saucepan, you know eventually it's going to get hot, right? It just takes a long time. So they conduct heat just really slowly. They have a low thermal conductivity. Whereas things like metals, like your metal saucepan, they conduct the heat really fast because those have the free electrons. So clearly when we're insulating our buildings, we're using things that have low thermal conductivity. We're using things that conduct that heat really slowly, okay? So let's say this was our house. Hopefully you're thinking, why have I used these red and blue colors? This is because we're looking at our house in a different wavelength of light, different part of the spectrum, okay? Because we're not going to use visible light here. So visible light is what I see things with. So you're seeing my information right now using visible light that goes into your eyes. This image here, where we can see where things are red or blue, hopefully you're thinking red is hotter. This is called IR imaging or infrared imaging. And you've probably seen that before, is like, you know, spy movies when it's nighttime and they're trying to see who they're going to shoot or what they're doing. They put these goggles on, they're called infrared goggles. And what they do is they let us see places where there's heat, things that are hot. Okay, so that's why we can see where a person is, because they look different from the tables, because they're hotter. So if we looked at our home in IR, we can see that the roof is really hot and we can see that the windows are really hot. But we can see that the walls are quite cool. Okay, so my walls are quite cool because they're blue. So you think, do you want your roof to be hot? Do you want your windows to be hot? And hopefully you're thinking, no, we don't want them to be hot. We want the heat to stay inside, right? We don't want this heat to go out. So you have to be thinking, how can I fix the roof, or what can I do to fix the windows so the heat stays inside? So something we can do is we can have double glazed windows. And hopefully you've heard of that, or heard your parents or your carers talking about it. Double glazed windows. And there it is, exactly what it says. Double glazed just means there's two panels. So instead of you sitting in your home and there being this one panel glass for you to see the trees outside, what there is there going to be two panels of glass. And you can kind of see that if you go to your windows and look at the side, you can kind of see there's a little gap between the two layers of glass. And the reason we have those two layers of glass is because it's because it'll be that little air gap in the middle. And we know that air is an insulator because it is a gas. Air has got a really low thermal conductivity. It's really, really slow at conducting heat. Because if you think about it, we just said these solids, you heat this one up, it vibrates, hits another one. Heat this one up, vibrates, hit the other one. But in a gas, if we heat this particle up and it vibrates or moves faster, it's going to take a long time before it hits the next gas particle. Because gas particles are randomly spaced and they fill up their whole space, right? They're much further apart. So because we have this little air gap now between the two windows, it takes a much longer time for that heat to leave our homes. So that means the heat will stay inside our homes for longer, so we stay warmer and we stay cozier for longer. We save money. Okay, so now you're thinking, what's wrong with the roof? Heat's getting lost for the roof, so something we need then is we need loft insulation. Okay, loft is a weird one to call it, because that's what they call the attics in America. So an attic is that top part of your roof, or if you live in a flat, you probably don't have to worry as much because unless you live in the top floor. But in the roofs, what we can put is thing called loft insulation. So same way as you wrap your body in a coat to prevent your heat getting lost outside, you basically just wrap the roof in a coat. So you put all this insulation up in your roof. Okay, so all this insulation roof. If you've ever been up there, you've probably seen it looks like this yellow foamy stuff. So the reason we put all that insulation up there, again, is because the insulators have a really low thermal conductivity. So it means that heat loss of surroundings will happen really slowly. That means the heat will stay in our home for longer. And then we are happier because we are warmer and we're saving money. Okay, these walls are pretty good, right? They're cool. They're not losing any heat. But some people might have walls that are bad. And the way we can fix that, an extra thing we can do, is we can use cavity wall insulation. Okay, so cavity wall, cavity, think about your teeth, you've got a cavity, got a hole. Cavity wall insulation just means instead of having one layer of brick between me and the outside, what we do is we basically put another layer of brick, so 2 layers of brick, and then we fill the inside with insulation. Because if we fill it with insulation, which has a low thermal conductivity, it means it takes a much longer time for that heat to get lost to surroundings. So cavity wall insulation is another thing we can do, but this person doesn't need it. Another thing we can do is that you can put a shiny foil behind your radiators. So I hope you're thinking, why would we do that? So again, this person doesn't need it because their wall's nice and cool. But if they had a radiator here, we know when we put our radiators on, we want that heat to come out into the room, right? I want it to heat me up inside my home. But that's attached to the wall. So heat might try to leave through the walls. And that's why the walls might be hot. It's not happening in this house because again, it's blue. But if that's something that happened in another house or in your home, the way we can prevent this from happening is we basically put this like silver shiny foil behind the radiator. So you just basically get the same thing you cook your chicken nuggets on, that aluminium foil, that tin foil. You just stick it behind your radiator. And what it does is it basically reflects the heat back into the room so that you don't lose it. Okay, so there's other things that we can do to save money in our homes. Okay, so that we're not using as much heating, we're not paying as much heating, we're saving money. So hope you find this video. Hit us and like and subscribe.